All right, what we're going to talk about here today is a wood chip gasifier based off of plans you can find on the FEMA.gov website. And what we're doing here is talking about ways that you can take wood chips or other carbon-based substances, as long as they have a very low water content, about 15% or less. You're able to put that into the top of the system here, and through a system of combustion and secondary combustion, it goes through the entire process, and what comes out in the end, it will be 118 octane fuel that you can use to power an internal combustion engine. So that's kind of the high view of what we're doing here. So when we start out, you're going to take the carbon, the wood chips, and you're going to put it into the top and you fill up the hopper. And you need to start the initial combustion with something, matches or anything like a normal fireplace would. But this system is unique in that it's a downdraft system. And so we have a fan on the back of the model right here. And that fan is we've got it from a salvage yard. This entire process here is almost entirely out of salvage parts. This is an automotive fan that just creates a little bit of a downdraft just to get things pumping. And inside of here is about a 2-foot long tube of 1/4-inch thick steel. And the initial combustion starts in here, and all the gas and the hot vapors go down through a chamber. And at the bottom of the chamber there's a stainless steel basket, and that basket will stop the charcoal in the bottom. And as that initial process goes down, the first combustion creates water vapor and carbon dioxide, which are great gases, but they're not very useful for powering an internal combustion engine. And when that water vapor and the carbon dioxide hits the charcoal, which is glowing red hot by now because of all the air that's been drawn across it, we get a secondary combustion that happens, and there's enough energy in that process to fuel a second chemical reaction. And in that reaction, we're actually going to chop apart the water vapor, and we're going to free off the hydrogen and free apart the oxygen from that. And the same thing will happen with the carbon dioxide, where the carbon dioxide will break into carbon monoxide. So from water vapor and carbon dioxide, we now have carbon monoxide and hydrogen. Both of those happen to be combustible gases, and that is what we want to bring all the way through the system and eventually power an engine. This is a very small system, but this system can power a 30 horsepower engine as long as you can feed wood chips into the hopper. So now that we got our two gases that we're looking for, we need to find a way to cool it down, because at 1800 degrees it's far too expanded to go down to the point where we can burn it down. So in between the combustion chamber and the outside of this tube, there's about a 6-inch wide plenum, and in that plenum we condense the gases down by cooling it. And by the time the air has worked its way up to the exhaust port here, and it comes out the exhaust port, it's only about 400 degrees, so we've made significant ground in cooling off that gas. Now when the system is up and running, there'll be a 6-foot pipe that connects these two areas, and that will continue that cooling process. As the vapors move along there, the heat continues to shed through the steel pipe, and we get to the filter mechanism. Now within this mechanism, the first half is just filled with river rock, and that river rock acts as a heat sink, and also any suspended particles in the gas at this point will condense onto the rock, and you can see there's creosote and other things that are stuck onto those stones. The air flows down, the bottom has got some holes drilled in it, and then it'll come back up on this side, and we chose wood chips as a filter medium just due to the fact that it's very easy to come by, and it has an immense amount of surface area locked into that area. That will continue the filtering process, and by the time the vapors get to this side, it's cooled down to about 120 degrees. At this point, we'll have about ready to turn the fan off, because it's cool enough and dense enough that we can power our internal combustion engine. And we'll fire up the engine, and right now we're only using about a 10 horsepower engine, and that will burn as long as we can supply it with carbon. We currently have it hooked up to DC generators, again, that we salvage from an auto yard, and we're just charging batteries with it at this point. A couple of things that we've discovered is, since we're not using everything on the system, unless we can really use all the gas, we're not running the system as strong as it could, and we had to install a bypass because we're getting water vapor condensing as well as some tar and creosote that pop out. When we have hooked it up to larger engines, maxed out the system, when it runs that high efficiency, we're fully gasifying all the vapors, we've lost the water vapor, and we've lost all the creosote. We get a great clean burn. Now there's 2 or 3 really cool things about this system as far as creating energy. The first is we're using a very renewable and very accessible carbon source here in the form of wood chips. The second thing that's great about it is we're creating heat. All the advantages of having a wood burner stove near your home, insofar as you can heat your home and as well as heat water with it, you can also do with our wood chip gasifier system here. Part of the system, after we've broken those molecules down, we want to bleed the heat off of it, so with a simple heat exchanger you can peel the heat out of the system and heat a domestic water supply. So we can actually, in a sense, have a backyard cogeneration facility where we're creating electrical energy as well as creating heat and heated water for your home. It's a very exciting system. The last part about the system that's very exciting is this is your byproduct, and what we have here is activated carbon charcoal. And when it goes all the way through and breaks down to this point, we're able to pull this off. And there's a couple of really neat things about activated charcoal. And first of all, that's almost essentially pure carbon. And there's a lot of talk these days about carbon neutral systems. And a carbon neutral is any system where you take a biomass particle and burn it for energy. The tree itself will fix the carbon out of the atmosphere, bring it down into the trunk, and when we burn this wood chip, it releases that carbon dioxide back into the atmosphere. So essentially we have added no net carbon to the atmosphere. The nice thing about a gasifier system is that half of the carbon that goes in turns into this charcoal, so we're essentially sequestering 50% of the input carbon into this form of charcoal, and this is a very stable form of charcoal, very similar to the fact of like coal or oil shale, and the fact that I could take that charcoal, bury it in the woods, and have my great-great-grandchildren come back and dig it up, and it's essentially going to look like just what it is today. And that carbon also has some really cool fun properties to it as well. The first of which is it can be a secondary fuel source. You could take this to another area. It's very similar to the charcoal that you use to power your grill. You can cook some hot dogs on it if you want, or you can use it in another area to power another wood stove and a secondary heat source. But what we like to use it for is the secondary property is activated carbon loves to have other things glob onto it. Just like in a fish tank, you can filter the water using an activated carbon filter. The same thing will work. You can filter water with this carbon if you want. But what we like to use it for is for using it as a soil amendment. When you take some of this charcoal and you add it to a soil, typically water-soluble nutrients like nitrogen and phosphorus will glob onto this charcoal and fix to it. And it will stay there in the soil instead of washing away in the rain. So you can take a relatively denuded soil like we have up here in the sand counties, and it will not necessarily add fertility, but it will keep the fertility that's there from washing away. And one of the great things about natural systems, they've found ways to use that nutrient. So a plant root or a tree root will come over to that carbon and secrete a little bit of acid to break that nitrogen molecule off and use that to grow more additional leaves. And now we've created a nice tight system as far as the fertility wherever we've added that additional activated carbon. It'll break off the nitrogen particle, it'll go up into the atmosphere, into the leaves. Those leaves will break that down, and that nitrogen will become back available, attached to the nitrogen, and the cycle just continues to perpetuate for hundreds and hundreds of years. So it's a nice, tidy, sustainable system. So not only do we have a cogeneration facility that we're making heat and electricity for a home in your own backyard from a readily available resource, your byproduct, your waste product if you would, actually helps heal the soil and sequester carbon from the atmosphere. Wood gasification is an absolutely critical technology that needs to be implemented across the country.
So the fuel that you're creating would typically be put into like a generator, like a gas-powered generator.
It could be, yeah. You can run any internal combustion engine off of it. Some of the common uses for that could be powering a water pump if you needed to pump water for irrigation. Generation is probably the electrical generation is one of the most common because it's very difficult to store the syngas. You would have to input additional energies and additional filtration to compress it down to a point where you could store it. But if you're able to create a generator, you can store it in batteries, and the technology for that continues to expand with lithium-ion batteries and other batteries. We're getting much better at storing electricity that way. There are other ways that you can use it immediately. In World War II, wood chip gasifiers powered most of Northern Europe once the blockades became into place. And you got into situations where there was millions of tractors and pickup trucks and cars that were being run with wood chip gasifiers. So you can hook it up to a moving vehicle and actually drive around in a car if you have a simple enough engine and a good enough gasifier.
Great.